Today we're going to be showing you how to do digital kits, small kits for kids at home. You can buy this kit here. It's a clock kit off of Amazon, and it costs about $10. And if you have a soldering iron, you can get from Walmart for about $5. You can show a kid how to learn how to do electronics. So this is just a basic soldering kit. That's all this is. And this is what comes inside of it. It did have a little cable with it for the power, but I don't have that cable anymore. But this is how it arrives. This is just a bare circuit board. And you see, there's all this is. It's a bare circuit board. And you have your different components you can solder onto it. Now hopefully everything else is here that we need. And it's very simple. You just stick it in like that. You're going to tack in 1/4 and 1/4 here for solder. And we're going to do this for all the rest of the components before we solder them all down, just in case we mess something up. So this is just cheap solder from Walmart and soldering iron. Now this could get kids interested in electronics and how it works. That's what we need in the world today, is people that know how to work on this stuff. So I'm going to get the big items first before I do the rest of the stuff. It's like that. This is what's called a resistor pack. There's many resistors inside of it, and it's just a package that's simpler in design. This is a regular resistor, and this is multiple of those resistors in one pin, and they have one bar across the top, and each one of those are basically parallel. And they have a dot here, and that's for pin 1. And that's how that fits. And you're going to solder that as well. We'll do one side. And then we'll do the next side. Actually, I was on the wrong thing. There. Okay. So we're going to move on to the other items. 10 microfarad capacitor. We're just going to work our way down. We'll zigzag back and forth. 10 microfarad capacitors. Now capacitors are like batteries. They have a polarity. Electrolytic capacitors, that is. And you do have a negative, which is what this sign is, and a positive. Normally on all of those, your lead's going to be longer for your positive. And on the circuit board, generally they'll mark on here where the negative side is going to be, and that's where that is, and the positive. Sometimes it's in a half moon shape. And we'll solder one of the legs down for this. And like I said, this is something you can buy off of Amazon for like $10. A quick little project for you and a kid or yourself. And they can learn about electronics. Let's move on. Transistor. This is Q1, and it says 8550, which is what the part number is for that. And I'm just going to stretch it just a hair, just like this. Hopefully you can see what I'm doing. Now notice the shape of the silk screen, and it's got this half moon shape. That's the same way with the transistor, as it follows the design on the circuit board, the silk screen. And then we're going to tack this down. There's a very small area to work with. Which would be perfect for a kid. Now, it might be ideal for you to solder outside instead of inside. You don't want to breathe the fumes. Got this big round thing on the circuit board here, and that's for the speaker. And on here it says remove seal after washing. So you can take and wash this board down with rubbing alcohol to remove the flux. But since everybody bought all the rubbing alcohol, I have none. But I'm leaving that seal on there so I know the positive side, which is also labeled onto the part itself. And just like the capacitor, the lead is longer. They do this for capacitors, they do this for LEDs, and they do that apparently for speakers. Kind of a sloppy job, but we'll make it work. Okay, so next we're going to do the little pick chip. Now you notice they have a little notch here, and that notch follows the same way on the chip package here. It actually holds the chip holder, I guess you would call it. As I'm soldering, I'm putting force downward onto the board so it have tension. But I'm also keeping my fingers away from any areas that might have heat applied. This is something that I recently did in a Boy Scout that I attended to, and help show those guys how to do this. And we'll give a little bit more solder to the chip socket or the IC socket. One pin here and there. And I'll put that in later. Next we want to take and put the resistor in. There's two resistors here and they have the same value. You could always take and cut each of the leads as you solder them. You do not have to do what I'm doing. You can just do this individually. Appears that I've added solder to the pad where the resistor was supposed to go, which is fine. I'll just give it a little heat and it'll push through. Just like that. There. Now we're going to use the other resistor over here. Okay, so that's there. And we have a couple other parts that are going to be a little tiny and kind of small. C2 is a small capacitor. C3, they're the same value. And then C4 is a different value. Those are all different ceramic capacitors, what they're called. And here's the 2, and here's the larger. On the silk screen it says 104, and then on the part itself it says 104. So that's the part you want to use for this. I'm just going to give it a little bit of solder there, just kind of tack it. Give it some more solder. There. Now here's one of those smaller capacitors. 30p is on the silk screen. You'll see that it says 30 on it. And they have their polarity for this. It's just sitting down right in there. And I'm going to bend the leads, spread them apart. That way it sits in there. Same way with this one over here. Bend its leads. And I'm going to solder those real quick. And then I'll do a little cleanup of all the leads that I have soldered. I'll cut them off. That way I can get to all the other stuff. And I always try saving these because you never know when you're going to need jumpers. That's what I use these for, is jumpers for circuit boards. If you have a good pair of cutters, that'd be better than what I have. These things are pretty ancient. Sorry for getting out of view. Cut the speaker lead. And cut this resistor lead. And cut this one. Cut this one. And I can cut the transistors. I'm going to save all them pins for something later. I might as well go ahead and resolder. We'll just solder this here. Okay, so I created a solder bridge. You'll see that that means I bridged 2 pins here with solder. Just use a toothpick or something that cannot conduct heat really well, and it'll remove the solder bridge. Okay, so now I can cut that lead. and get a new pair of cutters. Alright, so what's left is, this is your power cord connector, which I'm not going to use because I don't have the power cord anymore. Switches, and they apparently only go how they physically fit. And careful, when it pokes through, it might poke your finger. Just like that. Sometimes you have to make sure your parts go through. Sometimes they don't. Just like this one didn't. One of the switches, the legs, came out. I don't know if that would have made any difference, but definitely would not have been ideal. Okay, so all four are through. I'm just going to just solder all those. So you have to be careful when you do solder. Sometimes the flux will spit out, and it's kind of like bacon grease. It just splatters on your finger. It won't necessarily hurt you, but it just kind of stings you, and it'll give you a surprise if you're not prepared for it. Last object to solder, other than power wires obviously, is the crystal. And it goes in this little hole. And that'll keep the time of the clock going. So if you have this powered in with a battery, you always have the right time once you set it. This guy right here is basically your processor for the clock. It comes pre-programmed, so you don't have to do any programming at all. And it fits in the socket just like that. And that's what the circuit board looks like. And you can take and peel back the speaker if you want. I'm just going to leave it on. It'll muffle the sound. And then you can peel back this plastic layer here. You can see these 7-segment displays. I'm going to finish up soldering the rest of this, and then we'll apply the power, plug it in, and see that it works. going to take and cut the leads off. That way when I start to solder on this side for the resistor pack, it'll be fine. And I won't get any more solder bridges. We don't have a pair of cutters. 10-0 clippers will work. It's a little bit harder, but it will shoot off like projectiles, so you have to kind of be cautious of that. You don't want yourself or your child injured and having a little bit of play fun and learning about electronics. Alright, I'm going to solder just a little bit more. There. Now I can take and go down this row and then go on the opposite side. I just created another solder bridge. If I had a thinner tip, it'd be a lot easier to work with. Just like before, we'll take and remove it. There. Not the greatest soldering job, but it's soldered. Next I'm going to take, and since I don't have the original power cord and this is a 5-volt clock, I have an old junk USB cable. And I'm going to take and strip back the wires for the positive and negative. You just use a regular lighter. You can heat up the insulation. And you soften that up. And this will just gently press down, pressure, and it comes right off. So it's kind of a little MacGyver trick that a lot of people know. Alright, now to figure out which positive and negative. I got one line here that goes all the way around the board to the back side of this capacitor, which I already know that's the positive. So I'm going to put my positive in the middle here. And then I'll put the negative to the left there. I got one pad here. It's more for an anchor support, it seems. Be better if you tin your wires before you poke it through. And tinning wires is just basically you're adding solder to the wires. Give that a little bit more force. But now, what we can do is cut this white and green off. I'm going to poke the black through. I'm going to cut it a little bit. I got a little bit of blob of solder on the top on both wires. Put the black in here. And I'm going to bend it to the left. And I'm going to put the red. And I'm just going to bend it straight down. And now I'm going to solder those wires to the circuit board. And then I'm going to cut this here. I don't want it to be near anything that could cause any damage. And there you have your very own digital clock that you came from a kit. Now let's plug it in. I'm going to remove this cord back here. I'm going to plug this in and see that it works. And as you can see, I have a working clock, in which now you can take and change your time if you wanted to with this. It comes with instructions, but I didn't apparently keep those. And that's all there is to it. I probably will be getting some more kits like this and doing some YouTube tutorial stuff. And you can hear the alarm. Cool. Thanks for watching, guys. I'll see you next time.